Hello everyone, welcome to Excellence Batch Definite Integration lecture number 2, and this is going to be very important lecture as far as this topic is concerned, because we are going to do properties of definite integration in this today's lecture. Okay, so this is something very important. There are 8 properties in total which we are going to study in this particular lecture. So here we go. The first 3 properties are comparatively very easy. So let's first deal with these 3 first. Number 1, as I told you in indefinite integration as well, Shakespeare property. What's there in a name? If x in the integrand has been replaced by t, then nothing is going to get changed. Why? Because x has been replaced by t. So if x has been replaced by t, then dx is going to be nothing but equals to t. So this entire expression will now become f of t dt, and earlier x was equals to a, so now t will also remain x equals to a, and if x is equals to b, at that value t is also going to be b, so this is going to remain same. So what's there in a name? As long as interval of the integration is same, the variable name does not matter, is the property. Number 2 property is, if you interchange the lower limit and upper limit, then minus sign is going to come over here. Okay, yes. Second very important property. Okay, third property is, if you are integrating it from a to b, then you can integrate from a to c first and then c to b. It does not matter. It does not matter whether c lies in between, A and B or not. If C does not lie between A and B, then also this property is true, which is a misconception by majority of the people who have learnt definite integration. So we'll always do take care of this particular thing. So let's deal with this particular question. If you want to solve this, how do we solve such variety of questions, kids? So whenever you see modulus, your first agenda should be like this. Whenever you see mod of anything, you have to open the modulus. Okay, you will write down, if whatever is written inside the modulus, if this anything is greater than or equal to 0, you will open the modulus with a plus sign. That means you are going to write it down like this. Whereas if the thing written inside the modulus is negative, that means if anything is negative over here, then you will open this modulus sign with a minus sign, so that the overall thing becomes positive. So whenever you see modulus, you will have to apply this. So as we can see over here, that mod of 1 minus x is there, we can write it down plus 1 minus x if 1 minus x is greater than or equal to 0, and we can write it as minus times of 1 minus x if 1 minus x is less than 0. So the moment you simplify this, you will come to know that whenever x is lesser than or equal to 1, you can write it down like this, and whenever x is greater than 1, you can write down your modulus like this. Okay, so let me see over here that if we have to integrate from 0 to 2, so we can say that between 0 to 1, we can write down mod of 1 minus x as 1 minus x. Look from here, because whenever x is lesser than or equal to 1, we can write down mod of 1 minus x as plus times of 1 minus x. So we have to integrate from 0 to 2. So we are basically breaking this 0 to 2 into 2 parts. One is between 0 to 1, in which this interval is coming, and another one is between 1 to 2. Whenever x is between 1 to 2, you can write down your mod of 1 minus x as minus times of 1 minus x. So if you are fine with that, then you can write down your integral as 0 to 1. In that case, you can write down this as this. So 1 minus x dx without modulus, plus between 1 to 2, if you see, you can write down your modulus this thing as minus times of 1 minus x. So now you can see from here that you know how to integrate this one. It is going to be x minus x square by 2. You can put the limits 0 and 1, plus over here, if you see, it is going to be minus x plus x square by 2. You can put the limits over here 1 to 2, and then accordingly you will be able to get to your answer. So once we are putting x equals to 1, you are getting this. When you are putting 0, so you are getting this. Okay, that's it. Plus when you are putting 2, so it is going to be 2 square by this, minus when you are putting 1, so it is going to be like this. Now just write down the answer of this particular thing. Your question will be done. So whenever you see modulus, your first agenda will be to open it. So from there you got the idea that between 0 to 1 you can write down your modulus like this, and between 1 to 2 you can write down your modulus like this, and you know how to integrate these simple terms and you can get the answer quite comfortably. So 1 is coming out to be the final answer. I hope you guys are fine with this. Once we have broken this particular thing into 0 to 1 segment, and then it is 1 to 2, right? I hope you guys are fine with this. All right, moving ahead, talking about the second one. Whenever you see fractional part of x, you must know the graph of fractional part of x as well. Okay, let me tell you, the graph of fractional part of x goes like this. This line is y equals to x, this line is y equals to x minus 1, this line is y equals to x minus 2, and so on. This is 1, this is 2, this is 3, this is 0, and these are all 1. So basically this particular thing means what? This particular thing means between this area as well as this area, because 0 to 2 you have to integrate, means you have to find out this area. Now this thing can be find out pretty easily, because you know this value is nothing but 1, and this height is also equals to 1, so you can apply half into base into height. So this one area is going to be nothing but half. Similarly, this another area is also going to be equal to half. So half plus half, 1 is going to be the answer. So answer is going to be 1. This is one way of solving this particular question. But another way is what? We can write down fractional part of x as x minus greatest integer of x. Now greatest integer of x, the moment you see greatest integer of x, you have to find out greatest integer of x in this interval becomes integer at what values? So it becomes integer at 1. So we will have to break the question at x equals to 1. So the moment you break it, one is going to be like this and another one is going to be like this. Now in this case, if you see, your greatest integer of x is going to be 0. And in this interval, if you see, your greatest integer of x is going to be 1. So after putting all these values over here, you can write down x minus 0 dx going from 0 to 1. And over here, if you see 1 to 2, it is going to be x minus 1 dx. So I hope now you can integrate it. So let me tell you this thing once again. Whenever you see fractional part of x, your agenda should be to convert it into greatest integer function. And greatest integer can be dealt very easily if you know how to break it, or wherever the thing in between becomes an integer, you have to break that. So between 0 to 2, how many integers do come? Only one integer, 1. So that's why we have broken over here at 1. If let's say it is 0 to 3, then between 0 to 3, how many integers do come? So 2 integers, 1 and 2. So once we would have integrated 0 to 1, then 1 to 2, then 2 to 3. So that is how we have to proceed in order to solve the question. I hope you guys are fine with this particular thing. So the answer is coming out to be 1 from this particular method as well, bachcho. Alright, property number 4. Property number 4 is a very important property, and it is known as basically King's rule. Okay, it is basically known as King's rule, a very important property as far as JEE is concerned. So a to b f of x dx is always equals to a to b f of a plus b minus x dx. Understand, the limits are same, a b. Over here f of x is written, and over here f of lower limit plus upper limit minus x is written. So do take notice of this particular thing. These two things are both equal. The proof, if you want to see, let's say if you want to evaluate this, we can assume a plus b minus x as t. So the moment we assume, or we can do what? We can take the left hand side. Let's say we have taken the left hand side. This is the left hand side. Now here we have assumed x as a plus b minus t, let's say. So we can write down a and b are constants. So dx is going to be minus dt. So accordingly the limits will be changed, because this is x equals to a, this is x equals to b, but this is t equals to b, and this is t is equals to a. So when x is equals to a is there, if you put over here, so t's value is going to be what? T's value is going to be b. That's why this lower limit, when x is equals to b, you put over here, then t's value is going to be a. So that's why upper limit is t equals to a. So like this it is going to happen, kids. So now if you see what's there in a name, so t can be further replaced by a new x. So the moment you do it, you are going to get this particular thing, and you can say that left hand side and right hand side are both equal. A very special case of this property is special case is when a's value is equals to 0 and b's value is equals to a. In that case, 0 plus a minus x can be written over here. That is a minus x can also be written over here. So understand, a to b f of x dx can be written as this x over here can be replaced by lower limit plus upper limit minus x. So a plus b minus x is what replaced by in the integrand. So this is King's property, bacho. The application of this is very important. Let me tell you this thing, that when to apply this King's rule. Okay, when to apply this King's rule. After replacing f of x by f of a plus b minus x, if denominator comes same, then there are high chances that this property can be applicable. Denominator of the integrand comes same, then there are high chances that this property can be used. Understand over here, the denominator is 1 plus cos square x. So if we replace over here x by lower limit plus upper limit minus x, that is, if we replace this by x by pi minus x, is the thing going to be same? Yes, because cos square x is same as cos square pi minus x. Yes or no? Feel it, because cos pi minus theta is minus cos theta. If you do the square of minus cos x, it is going to be cos square x only. So these two things are equal. So you can see that if we replace f of x by f of a plus b minus x, if the denominator comes same of the integrand, then there are high chances that this property is applicable. So let me apply King's rule. If we are calling this thing as I, then after applying King's rule, the limits are going to remain same, but we can replace every x by pi minus x is what we have seen. So if we are replacing every x by pi minus x, then the question is going to look something like this. If you look at this, then this very same thing can also be written like this: pi minus x times, what is sine pi minus theta? It is sine theta only, and it is going to be like this. So what we do is, we take this one and we take this one and add these two. Something good is going to happen. 2i is going to be same in limits, so we can combine the two integrands and we can write down x sine x upon 1 plus cos square x plus pi sine x minus pi minus x sine x minus x sine x upon 1 plus cos square x dx. So over here you will observe that few of the terms are getting cancelled, and the system is going to, and the question is going to get a bit simplified now. So you will see something like this. And now this function can be integrated relatively very easy. Why? Because cos x can be taken as t and the problem can be solved. So I hope you will be able to solve this one quite comfortably, everyone. Yes or no, everyone? Have a look at this. So this is one thing whenever we need to apply the King's rule, and another thing is what? Whenever we have unwanted x, we can use this property. Okay, whenever we have unwanted x, look over here, this x is unwanted. Why? Because all the terms are trigonometric terms. Apart from this, this is the only algebraic term, right? So this is an unwanted x. In order to remove this, also we can use the King's rule. Okay, the King's rule is what? X can be replaced by a plus b minus x. That is lower limit plus upper limit minus x for each and every x in the integrand. Okay, yes, do not forget to write down dx over here. Okay, so that is the thing. So now this function can be integrated quite comfortably, because sin x can be, cos x can be taken as t, and the thing will be simplified. Okay, yes. So don't forget to change the limits in these scenarios if you are using substitution method. Okay, yes. Over here what will be done is, cos x will be taken as t. Now if you differentiate this, so dt by dx is going to be minus sin x. Alright, so sin x dx is going to be nothing but minus dt. So you can write down this particular thing as minus pi dt divided by 1 plus t square. But don't forget to change the limits as well, because when x is equals to 0 is there, t's value is going to be what? Cos 0 is nothing but 1, so t equals to 1 it is going to be, and when x equals to pi is there, t is going to be nothing but minus 1. So you have to solve this limit then. So minus pi can be taken outside, and it is going to be 1 upon 1 plus t square dt. So you know how the integration of this happens. So it is going to be minus pi times of tan inverse of t, and then put the limits over here, t equals to 1 and t equals to minus 1. You will be able to reach to your answer quite comfortably, everyone, and the final answer is coming out to be pi square by 4. The reason being that this is the value of I, okay? Yes. So the answer is going to be pi square by 4. Okay, over here also look, if you see this, then let's call it as I. The moment you apply King's rule, then you will notice that the x will be replaced by pi by 3 plus pi by 6 minus x. That is, this is also equals to I, which can further be rewritten as pi by 6 to pi by 3 dx over 1 plus cot x. Now this cot x can further be written as 1 by tan x. And now this can further be rewritten as tan x upon 1 plus tan x, where it is going from pi by 6 to pi by 3. So all these values are equal to I and I only. So let's add this one and this one. So this I and this I, if you add, it is going to be 2I. And on the right hand side, it is going to be something like this. This thing. And since the limits are same, the two terms can be clubbed. And if the two terms are clubbed, you are going to have something like this. Tan x plus 1 upon tan x plus 1. So it will be cancelled. So it is going to be nothing but pi by 3 minus pi by 6. That is equals to pi by 6. So now you can say that 2I is equal to pi by 6. So I is going to be how much? It is going to be pi by 12. So pi by 12 is the correct answer for the particular question, everyone. Have a look at this, right? I hope you guys are clear with this. All right, moving ahead. Let's talk about this particular property. We have to find out I1 upon I2. Okay, yes, and I1 and I2 are the two things given to me like this. Okay, yes, our agenda is to find out I1 upon I2. So do try to solve this particular question. I am attaching the solution for the same. I think you will be able to do this. All right, talking about property number 5. Okay, so let's go and discuss property number 5. Okay, whenever you have minus a to a as the lower limit and upper limit, this thing, if f of x is odd, if the integrand is odd, this is nothing but 0. The answer is going to be 0. And if f of x is an even function, this is an even function, okay? And if f of x is an even function, then the very same thing can be written as twice of 0 to a f of x dx. Okay, yes. This property we will use whenever the limits are going from minus a to a. Okay, yes. So this is the thing. The proof of this is what I have attached for your reference. You guys can check it out without any issues. So understand over here, the moment you see minus a to a, so minus a to a, can you guys feel it over here? So your agenda should be to find out, check whether is odd or even function. This function is odd or even. So let me tell you, this is odd function. Odd. Why? Because this is f of x, and if you look at this, f of minus x is going to be minus times of f of x. That's why it is nothing but an odd function. Okay, and also you guys can see that this is an odd function, this is an even function. So odd into even is always going to be odd. So that's why this is odd, and if this is odd, you don't even need to calculate it. The answer is going to be nothing but equals to 0, because the integrand over here is an odd function. That's why. Okay, beta. Yes. All right. I hope you guys are clear with this. Moving ahead, talking about this is odd or even. So let me tell you that cos of minus x is equals to cos x only. So this is an even function. If it is an even function, then we can write down twice of 0 to pi by 2 cos cube x dx. Now can we integrate this, everyone? How to integrate this? I hope you guys know how do we integrate cos cube x. So for that we have seen cos 3 theta is equal to 4 cos cube theta minus 3 cos theta. So you can write down from here that cos 3 theta plus 3 cos theta upon 4 is nothing but equals to cos cube theta. So cos cube x can be written as, by that particular formula, cos 3x by 4 plus 3 by 4 cos x dx. And splitting about the plus sign, I'll think you will be able to integrate it one quite comfortably. Have a look at this, everyone. Yes, so that will solve your problem, bacho. This is what you have done. Then how do we integrate cos cube x is what we have seen in indefinite integrals, and accordingly the final answer is going to be 4 by 3. I have attached this calculations for you and you can do this one quite comfortably. Whenever you see minus a to a, now understand, over here some part in the integrand can be even, some part in the integrand can be odd. So let's do one thing. Whenever we see minus a to a, we have to collect the even parts together. So if we see the odd parts, so this is going to be the odd part plus this is going to be the even part. We are not concerned about denominator. So this is odd, so that's why it has to be 0. So the overall thing is going to be minus root 2 to root 2 and something like this, 3x ki power 6 minus 12 this plus 1 by x square plus 2 dx. Now our agenda is to deal with this. So I can see that x square is mentioned every time in the integrand. So this can be written as x to the power 3 ka whole square, I guess. Yes, or x to the power 2 ka whole cube. So what we can do is we can put t is equal to x square. So the limits are going to change. So is it going to work? No, it is not going to work. So we can first write it down twice of 0 to this because it is an even function. And after that you will be able to integrate this one quite comfortably, I guess, because you can put x square equals to t. So when the limits are going to change, do take note of that. When x is equals to 0, t is going to be 0. When x equals to root 2, then t is going to be 2. And then this is going to be what? 2x dx is going to be nothing but equals to dt. So x dx can be written as dt, but over there no x is there. So accordingly it is going to create a bit trouble for us. But I think you will be able to integrate this one quite comfortably. So just try doing the integration of this. So what we can do is rather we can split about this plus sign as well if possible. And is it going to help us? Do take a note of that, everyone. So this is what we have written at the end. Right, this is what we have written at the end, and this can be further rewritten like this, and accordingly it will help you to solve the problem, bacho. Right? So do try solving it from here, and after that I believe you will be able to do this. Why? Because if you split about this plus sign, then this can further be written as a square minus b square wala property you can apply, a plus b into a minus b. So about this plus you can split, and then the remaining problem can be solved by integration pretty comfortably. Right, everyone? Okay, property number 6 is what we're gonna study now. So this is what, that whenever we are integrating from 0 to a, we can write down this thing as 0 to a by 2 f of x plus f of a minus x. Understand that over here the upper limit is a and over here the upper limit is a by 2. Whenever we need to reduce the upper limit, we can use this property. Whenever we need to reduce the upper limit, we can use this property. So a has been replaced by a by 2 over here in the integrand. Understand, over here f of x plus f of a minus x is there. If f of x and f of a minus x are minus times of each other, then the answer is going to be 0. If f of x and f of a minus x are equal, then it can be written as twice of this particular thing. So remember this property as well. When we use this property, we use it whenever we have to reduce the upper limit, bacho. Right, so let's go through it. So it is 0 to pi written. So if you want to reduce the upper limit, we can write it as 0 to pi by 2 f of x as it is sin 2kx divided by sin x plus f of a minus x. Now a's value is what written over here. So f of pi minus x is what we're going to write down. So we can write down 2k times pi minus x. X will be replaced by pi minus x. Okay. So this is what we will be writing down, everyone. So this is what we are having. Now this thing can be written as what? 2k pi minus 2kx. So this can be written as further sin 2kx. And this can further be rewritten as sine of x only. So this entire thing is going to be something like this: 2 times of 0 to pi by 2 sine 2kx upon sine x into dx. Right, everyone? So now our agenda is to solve this particular thing. Okay, yes. Can we guys solve this one, everyone? Yes, can we guys solve this one now? So I think it is coming minus times of each other. Okay, wait. Yes. Oh, sorry. So it is going to be minus. So if it is minus, then it will be answer. It's the two terms are going to get cancelled. So the answer is going to be 0. Okay, so the limit a is reduced to a by 2. So in order to do that, we have used this property, guys. I hope you guys are clear with this. All right, talking about the 7th property. If we are given some limit and we want to make the limits 0 to 1, this is usually done in the case when different integral terms are given to me and all of them are having different limits. So to combine all of them, what we do is we convert all of the integrals from 0 to 1. Okay, this property is used to make limits same in different integral terms. Okay, so this property is used in those particular cases. So let me talk about an example of this. Let's say you want to solve this question. Now over here, look, two integral terms are involved, but understand the lower limits is -4, -5, 1 by 3 and 2 by 3. So different things. So what we can do, we can apply this property number 7 over here as well as over here. So what does that property say? It says that a to b f of x dx can be written as b minus a times 0 to 1, b minus a is in multiplication, f of b minus ax plus a dx. Okay, yes. So this can be used. So we guys can write it down: upper limit minus lower limit, that is -5 minus of -4, integral of 0 to 1 f of, that means x will be replaced by what? That means x will be replaced by -5 minus -4 x plus a means this. So it is how much? X will be replaced by minus x minus 4. So x will be replaced by minus x minus 4. So let's do it. X will be replaced by minus x minus 4. If you do this, you are going to get this. Okay, plus 3 times of the very same thing is what we guys are going to do over here as well. So 2 by 3 minus 1 by 3 times of 0 to 1. And then over here, x will be replaced by 2 by 3 minus 1 by 3 x plus 1 by 3. So x can be replaced by x by 3 plus 1 by 3 in this case. So if you replace x by 3 plus 1 by 3 minus 2 by 3, this is what you are going to have, and now the limits have been made same, so you can club these two integral terms and accordingly you will be able to solve the problem, bachcho. So this is I1, the first integrand. As we have seen, it can be written like this upon simplification. Similarly, I2 is the second integrand, which after application of the property can be written like this. And I1 plus 3I2 is coming out to be equals to 0. So I think you can have an idea from here, which is pretty easy and it can be solved quite comfortably. Property number 8 is used in case of periodic function. If a function f of x is a periodic function with, let's say, period t, then f of x plus t is nothing but equals to f of x. Yes or no? So let's feel this property over here, that if you have to integrate from a to a plus nt, then you can see that n time intervals have taken place in this particular interval, because the length of this is nt. So basically t times t interval has been covered n times. So you can write it down as n times of 0 to 2 f of 0 to t f of x dx as well, everyone. Okay, in these scenarios, if a is equal to a is any value, then also it is fine. If a is 0, then it will become 0 to nt. Okay, like that. So not an issue, right? Yes. So it is there. Second, if n is equals to 1, then it is going to be a to a plus t. So it is basically one time interval, the length, the difference between these two. So it is going to be 0 to t only. If it is mt to nt, then it is going to be n minus m over here, and then 0 to t, same thing. Okay, yes. And if it is a plus nt till b plus nt, so you can write it, see that the difference between these two is nothing but b minus a only, which is from a to b itself. Yes, so you can write it down like this as well. So if you want to integrate this, I hope you guys know that the graph of cos x looks like this. So this is the graph of cos x, this is 2 pi, and similarly this graph is going to get drawn. So this is how the graph of y equals to cos x is drawn. Okay, y equals to cos x is drawn. Now if you see the modulus of this, then this is removed and this will come over here like this, this will be removed and this will come over here like this, and so on. So you guys can see that this is first region, this is second, this is third, this is fourth, this is fifth, this is sixth, this is seventh, this is eighth. So this is a periodic function, right? So 8 times of 0 to pi by 2 is going to be your answer, 8 times of 0 to pi by 2. And in that case, mod cos x can also be written as cos x, because 0 to pi by 2 cos x is always positive. So then your question is done. I hope you guys are fine with this. 8 is the correct answer. Yep. So that is there. Right. Yes. So you guys can see it, that it can be solved pretty comfortably like this. All right. Talking about this, show that this 0, say n pi plus mu, this value, talking about this. So you guys can write down this particular thing as 0 to n pi as a separate entity, and then you can write down n pi till n pi plus this mod sin x dx, and this thing by the usage of property can further be rewritten as 0 to this mod sin x. So now I think you will be able to solve, because this is a periodic function. So this can further be rewritten as n times of 0 to pi mod sin x dx, and then this can be solved also pretty comfortably, and you will be able to do this, right? Solution I have attached for your reference, kids. That's it for the day, guys. I'll end the session here only. Don't forget to solve the PPTs, DPPs which are given to you. That's it for the day. Keep learning, keep shining, keep rocking, keep enjoying. Let's make most out of this. Thank you so much. Bye bye. Take care. Happy learning, bachcho.